How do operating systems actually boot up? Have you ever wondered what happens when you press the power button on your computer? The boot process is a fascinating journey that transforms a lifeless machine into a functioning computer. Let's break it down step by step. When you turn on your computer, the first thing that happens is the hardware receives electricity. This activates essential components, including the processor and the basic input-output system. The basic input-output system is firmware stored in a chip on the motherboard. It plays a crucial role in starting up your computer. The first task of the basic input-output system is to perform a power-on self-test. This test checks the functionality of critical hardware components like memory, disk drives, and input-output devices. If there are any issues, the system will alert you with beep codes or messages on the screen. Once the power-on self-test is successful, the basic input-output system looks at the boot order. This is a prioritized list of devices that the system will check for bootable media. These devices can include hard drives, CD or DVD drives, USB drives, or even network sources. The basic input-output system searches these devices for a special data structure called the master boot record, or, in newer systems, the GID partition table with an FI system partition. When it finds the master boot record or its equivalent, it loads the bootloader program into memory and hands over control to it. The bootloader is a small program that is responsible for loading the operating system kernel into random access memory. Different operating systems use different bootloaders. For example, Windows commonly uses the Windows Boot Manager, while Linux systems often use the Grand Unified Bootloader. macOS has its own boot mechanism based on the extensible firmware interface. After the bootloader takes charge, it loads the operating system kernel. The kernel is the core part of the operating system that manages hardware resources and system processes. Once the kernel is loaded, it initializes essential services and device drivers. These drivers enable communication between the operating system and hardware components like keyboards, displays, and storage devices. Finally, the operating system completes its initialization by starting system utilities and user interface components. This includes the login screen or desktop environment, allowing you to interact with your computer. Different operating systems have variations in their boot processes. These differences mainly involve the bootloader used, the firmware interface, and how the operating system kernel and drivers are loaded and initialized. For instance, modern Windows and Linux systems typically use UEFI firmware, which supports faster boot times compared to older basic input-output systems. macOS uses a version of UEFI specifically designed for Apple hardware. Understanding the boot process is essential for troubleshooting startup issues, configuring multi-boot systems, or customizing system startup behavior. It is a fundamental concept in operating system management and usage.